Hello. In this video, I'm going to try to explain to you some special properties of water. Water is extremely polar, and I have a video about that. But basically it means that one part of the water is negatively charged, and another part of it is positively charged. Therefore, it's going to act like a little magnet with positive and negative poles instead of north and south poles. Now this polarity leads to several very important behaviors. This is a list of them. I'm going to go through them all. First, let me talk about hydrogen bonding. So a hydrogen bond is created whenever a relatively positive hydrogen in a polar molecule is pulled towards a relatively negative atom in another molecule. Two polar or electrically charged molecules will attract each other because think of it like little magnets. The positive and negative ends, the opposite ends, will attract each other, just like magnets would. And this would happen with the atoms themselves. They would be pulled towards each other. So a hydrogen bond is going to be created whenever you have a hydrogen in one polar molecule attracted to some negative part of another polar molecule. That line, that's the hydrogen bond. It's like a magnetic attraction, except it's electric. It happens between this hydrogen, which is positive, and that oxygen, which is negative. It's normally going to happen with a carbon, nitrogen, oxygen, or a fluorine. And this is what it would look like in 3 dimensions. On the right, you can see an animated picture of several water molecules that are hydrogen bonding. And on the left, you can see a static picture with the hydrogen bonds as dotted lines. Let me talk about cohesion now. Cohesion describes water's tendency to stick to itself because of this hydrogen bond it makes with other water molecules. As an example, if you have a lot of water molecules in a line and you let them move wherever they want, they're going to end up moving next to each other because the positive and the negative ends are going to attract and stick. So if you look closely, you'll see that the hydrogens are sticking to the oxygens and vice versa. This is one of water's most important behaviors, and it actually causes many of the other properties I'm going to talk about in this video. It's also why water likes to make beads and domes instead of puddles, and it's why when rain hits your windshield, it makes these little droplets and it doesn't just roll down into sheets. Now let me talk about adhesion. Adhesion describes water's tendency to stick to other non-water substances that are also polar or electrically charged. Basically, adhesion is when water sticks to other things, like spiderwebs or plants, for example. The difference between cohesion and adhesion, it's the same basic principle. It's these polar molecules being attracted to other electrical charges. But cohesion is when water sticks to itself, and adhesion is when water sticks to other things. Now let me talk about capillary action, or you could pronounce it capillary action. Capillary action occurs when a combination of adhesive and cohesive forces allow water to climb up a little tube, and it moves it against gravity. On the left I have an animation, and on the right I have a real picture of green water going up into a little metal tube. Tiny tubes are called capillaries, or capillaries, which is why it's called capillary action. Now let me talk about surface tension. Surface tension is the property of water that makes its surface act kind of like a solid elastic membrane. It acts sometimes like a solid, not a liquid. It happens because water molecules form these hydrogen bonds with each other, pulling each other in, and so water sticks to itself and acts kind of like a jelly. This makes the water's surface act a little solid, so it'll hold some objects as long as you don't puncture through and break that tension. Kind of like plastic wrap. You can put something on plastic wrap and it'll stay until you get a little rip in it, in which case it lets itself through. This is why if you're really careful, you can make objects that are denser than water, like coins, paper clips, or needles, float on top of it, because of the surface tension of the water. It's also why certain insects and animals can walk on water and even jump off of it. Now let me talk about high specific heat. This one is going to be a little bit more technical than the others. I'm sorry. So specific heat is a measurement of how hard it is to make something increase or decrease in temperature. For example, let's say you wanted to heat up 1 liter of water from 0 to 100 degrees. Now, how long would it take for you to do this on a normal stove? the water needs to absorb about 400,000 joules of energy in order to go from 0 to 100 degrees. And don't worry about where I get this number from. The stove would deliver that much heat in about 10 minutes. If you wanted to do the same thing with castor oil instead, how long do you think it would take? I mean, it's the same amount of liquid, and you're taking it from 0 to 100 degrees again, so you might think it would take the same amount of time, but it doesn't. This oil needs to absorb about 188,000 joules of energy to get that hot. And the stove would deliver that in about 4.7 minutes. So oil would take about 4.7 minutes to go from 0 to 100 degrees, and water would take 10 minutes to go from the same temperature to the same temperature, 0 to 100. This is because water needs more energy to heat up than oil does. Basically, water has a high specific heat, and that means that it's very difficult to change its temperature. It'll happen very slowly, not quickly. It's why pools are cold even on very hot days. It's because the whole day isn't long enough to make the pool heat up. And it's also why coastal areas like Hawaii are warmer than landlocked areas in the winter. It's why you want to go to Hawaii on your winter vacation. It's because the entire season isn't long enough to cool the ocean down, and then the ocean acts like a heater, warming up the surrounding environment. Now let me talk about liquid density. Water is one of the only chemicals that we know about that is more dense as a liquid than a solid. And that means that solid water, which is ice, will float on top of liquid water and doesn't sink down. Normally, this is how the particles look like in a solid, liquid, and a gas. Notice how the solid form is the most closely packed together, because it's moving the least. But the real difference between the states of matter is not how dense the substance is, it's how much the particles are moving. Therefore, if there was a chemical that was further apart when it was standing still than when it was moving, then the liquid version of it would be the most dense, because when it was moving around, it would be closer together. So let's think about water. It's really more like this. The oxygen is negative and both of the hydrogens are positive because of its polarized nature. And if you had a lot of these, try to think about how you would arrange them so the positives and negatives connect together. Now you wouldn't be able to just arrange them in a straight line. You want every negative part to be close to a positive part, but they're arranged sort of like triangles. And it turns out it would look something like this. They would form a sort of loop. That would be the best way to connect every single negative to a positive. So if you have a bunch of water molecules and you let them stop moving and settle down, they're going to form these hexagon loops that have a lot of very empty space inside of them. And this makes solid ice less dense than liquid water, because the solid ice has all this empty space in the middle. But the liquid water, because it's forcing the particles to move, breaks this structure down, so they bump into each other more often. So water is more dense as a liquid than as a solid. And that's why ice floats. Finally, water is a universal solvent. It's called a universal solvent because it can dissolve a lot of things. And this is actually important enough to get its own video, and I'm not going to cover it very much here. So review. Water has hydrogen bonding, which means that its polar hydrogens get attracted to negative oxygens. It exhibits cohesion, meaning it sticks together. It exhibits adhesion, meaning it sticks to other things. It has capillary action, meaning it goes up little tubes. It has surface tension, meaning that the surface acts kind of like a solid jelly. It has a high specific heat, meaning that it's difficult to heat up or cool down. It has a high liquid density, so its liquid is denser than its solid. And it's a universal solvent, meaning that it dissolves a lot of things. I know that's a lot, but if you can remember that, then you will have learned everything you were supposed to from this video. I hope that was helpful.